Okay, so we know what flow time is, total flow time, and how to calculate that, right? So I know the question that was in your minds. So we can observe the process, like being the being a direct method. We're going to look and observe the process, like staying there for hours and hours and hours. We can take some random sampling and find out. We can mark a unit and see how long it takes. Or we can look at average times and see how that works, right? And collect some data here and there. You can also have an indirect method where you basically looking how many units you have there and estimating a time that takes to go through the whole process steps, right? So that's called an indirect method because you're not kind of collecting data about each individual observation at a time. You're just calculating the inventory and the throughput rate to calculate that the inflow when he does that. Here and we use the Little's law. So maybe had in previous operations management core courses talking about waiting lines. So that's the basic concept of waiting lines, right? So you have your inventory, you have your inflow, and then you can calculate how long on average those products are going to stay there, right? And pretty simple way to calculate that will be the inventory divided by the throughput rate or the inflow rate, the frequency that things are going out, right? So let's say I have 100 items into process. It's getting out one every 1 minute. So on average, they have to stay there 100 minutes, right? Because it's going to be 100 divided by 1. So you can calculate that pretty quick, pretty easy, just to look at the inflow rate of that process and getting that frequency and looking how many items you have in the process. That's called the Little's law. That's coming from Waiting's line theory, okay? And you can use that also. We're going to use a little bit kind of a modification of that sometimes in the lean section. So just here an example, I have here process has 2,000 units of work in process inventory and the demand is 500 units per day. So what is the actual flow time? So the inventory 2,000. The rate is 500. Inflow rate is 500 units per day. So 2,000 divided by 500. So I have an average. It takes an average 4 days to go through the process, right? So pretty simple, basic way to have a rough estimate of the total flow time. So now we get to a very important concept here where we're going to use it a lot. So this is a very important slide here. It talks about the core versus actual flow time. Okay, so when we're talking about the core processing time, we're looking only at the process steps that are adding value to the project to the process, right? So basically, an example there, if you're buying a coffee at Starbucks, they're going to register and actually making you coffee and give it to you. That's basically the two steps that add value to the project. Waiting between those steps don't add value, right? So the core processing times, remember that name, core processing time, are the ones that are done by those steps, right? So maybe that's the 2 minutes of time that we're actually adding, creating value to the customer. The total flow time encompass not only those two, but also the waits between those two steps, right? Waiting before or after each step. So the total flow time takes in consideration all the time between the beginning and the end, and the core processing time adds only the transformation steps. Okay, so that's what basically saying here. The actual flow time is going to be 4 days, but it captures core processing time and waiting time. Core processing time is the value added, waiting time is the non-value added, all the waste, right? And the flow time efficiency is going to be core processing time divided by the actual flow time. Basically means what is the percentage of the total time that you're actually adding value. So let's say that we took 20 minutes for me to get my coffee. That's a long time. The line was big. 2 minutes is value added time, which is actually getting my order and making my coffee, means that 2 divided by 20, it's only 10% of the flow time efficiency, right? So 10% of the time that I was waiting was actually creating value for me as a customer. Okay. So some challenges calculating the flow time. Sometimes I have different types of products and patients with different mix and different routes. So, if you go to an ER and if a patient have this problem, go this way, and if you have this problem, if you have a broken arm, you go to X-ray. If you're, have other symptoms, and you go to, lab and take some exams and take your blood. So if you broke your arm, you're not going to take your blood, but if you're feeling a pain in I don't know, in the belly, maybe they're going to take a blood to see what's going on. So you have different types of patients and they follow different flows, right? And then they have different flow times because of that. So that makes things a lot more complicated. We're going to learn how to do that also. So sometimes a little bit difficult to understand the boundaries, the X's, and what is it getting in and getting out. Sometimes also computed activity time, could be very, very different from one time to another, what time to use, and also considering rework, right? Rework is important to be considered. Rework is basically the time that you have to go again. What is the percentage of the units that go to a process have to go to again, right? The same process. And that happen depending on the business quite often. So just for example of the rework, I work in a company that produces bottles, glass bottles, and about 15% of their bottles actually got broken, and then they can use all the material, which is glass, right? If it breaks, they can go again and put it in kind of a big uh, fire and pan again, right? Is it like a stove or whatever? Put a lot of heat there and make more glass. So although they can use the 15% that got broken, they have to put that back in the process, so they lose the ability to produce 50% more, right? Because they're always using the old one and always having less, right? And a lot of other industries that happen, wood industry also that I worked quite a bit, have that rework or yield kind of things to count for.